Hello everyone, Nicole Steckline here, Technical Agronomist with DeKalb Asgrow, and welcome to Nicole's Craft Classroom. With nitrogen application season quickly approaching, I wanted to take a few minutes to talk about our different forms of nitrogen fertilizer and what happens to them in the soil that influences their availability to our crop and our risk for losses. Okay, so here is our nitrogen cycle, and as you can see, it's very clustered. There's a lot of things going on here. The nitrogen cycle itself is very complex, and there's a lot of reactions that happen that have a lot of implications on our cropping systems. But I think I want to break it down into maybe some little smaller, easier to understand categories so we can think about how this nitrogen cycle impacts our cropping decisions. So I want to first break it down into two different groups, being inputs and losses. So our inputs, obviously, what we think the most about is our fertilization. So this is using our Anhydrous, our Urea, and our UAN solutions. Mineralization, which is a microbial process. These are the microbes decomposing our organic matter and releasing the nitrogen that's stored within our soils. And then we've got fixation, which is another microbial process. As important in our crop system, we think mostly about soybeans and alfalfa, where we are making those symbiotic relationships with nitrogen fixing bacteria. And then on the other side, losses, obviously we're going to be taking some of the nitrogen out when we remove our grain. Leaching, which is probably the number one form that worries us, particularly when you think about groundwater quality. Denitrification here, so probably we aren't giving enough credit to denitrification. So when we have saturated soils, this is taking that nitrate form of nitrogen and turning it into nitrogen gas, which is then released to the atmosphere. And then we've got volatilization, which is the main process when we think about loss to the atmosphere when we surface apply urea and urea containing fertilizers. So let's look quick at our most widely used nitrogen fertilizers in Iowa. So anhydrous ammonia, very widely used product. Anhydrous ammonia, so what the name actually refers to, anhydrous is a word that means water seeking or water loving, which is one of the reasons why it can be so dangerous and you end up with those nitrogen burns. When you get that anhydrous on your skin, it's actually pulling the moisture out of your skin and your tissues. And then ammonia, which refers to the form of nitrogen that is being delivered in. Anhydrous ammonia comes in a 100%. It's all in the ammonia form, all in NH3. And we handle it as a compressed gas. So when you look at those storage tanks, you look at those nurse tanks, those are applying pressure and it allows it to stay in a liquid form. NH3 wants to be a gas, so we have to compress it and it leaves it in a liquid form. When we put it through our toolbars, once it comes out of those coolers, gets released through those knives. If it's not being incorporated into the soil, and if it can't find water right away, then it'll go up into the atmosphere looking for water, and then we've lost some of our product that way. The most common form of synthetic nitrogen fertilizer is urea. Urea comes in a dry prill, and it all comes in 100%. It's all in the urea form. And then we've got our liquid solutions. UAN, which stands for urea ammonium nitrate. There's two main forms of these, which is 32% and 28%. Just means that the 28% has a little bit more water. We use a lot more of the 28% in the early spring in Iowa, especially if you're going to store it in Iowa. Now, it's a little bit counterintuitive because you think, okay, well, if I have more water in the 28% than the 32%, then won't it be harder to store because it's going to be more likely to freeze? But the issue is keeping it in solution. So the 28% has more water, which means that there's less salts in it. The issue is not freezing. The issue is salting out when we have too high of a concentration, this 32%, when it gets a little bit colder. So urea ammonium nitrate, 50% of that nitrogen is going to be in that urea form, 25% will be in that stable ammonium form, and about 25% of it will be in that nitrate form. So as far as plant utilization, the plants are going to be using nitrogen in the ammonium and the nitrate forms. It needs both of these forms, and in differing ratios. I don't think anybody's really come up with the what's going to be the perfect ratio for these two. But let's look at each of these fertilizers individually and talk about the soil processes that happen with them. So first off, let's talk about anhydrous ammonia. So anhydrous ammonia, as we said before, is 82% nitrogen. This makes anhydrous a very efficient form of nitrogen fertilizer where we aren't having to handle near as much bulk to get the amount of nitrogen in that soil as we want. So we've got the tank out in the field and we're applying that nitrogen. And we need some moisture in the soil, not that we want to do it when it's really wet, but we need moisture in the soil because that ammonia doesn't like to be ammonia. It is not a happy compound as NH3. So what it does is it will steal a hydrogen from water and tack it onto itself and make itself happy so we can end up with ammonium. Now, this is another reason why anhydrous ammonia is a good form of fertilizer, is because relatively 100% of the original form of nitrogen is then converted in the soil into a stable form. So when I say a stable form of nitrogen, I say one that is not going to be easily lost to the environment. So we have moisture, so we aren't going to lose it to the atmosphere. And then when you think about our soil has a net negative charge. And ammonium has a net positive charge. So if you think about magnets, if our soil is negatively charged, the ammonium ion is positively charged. That's how we're keeping this form of nitrogen stably in the soil and keeping it there for the plants to utilize as it's growing. So obviously, it's not going to be able to stay in that form because nitrogen is constantly moving and changing in the soil. So what happens to ammonium in the soil, there are nitrifying bacteria. The first one that we worry about is nitrosomonas. And that nitrosomonas, over a period of time, is going to turn that ammonium into nitrite. Now, nitrite is not available for the plants, and it doesn't stay in this house for very long. It will very quickly be converted by nitrobacter into nitrate. Now, nitrate is plant available, and the plant needs to have some of its nitrogen supplied in this form. The issue with it is that it's got this negative charge, and like we discussed before, is that our soils are negatively charged as well. So when we have those the negatively charged soil and the negatively charged nitrate particle, then that nitrate will be able to move through the soil, and then we have leaching where it can end up in our groundwater. So something else that can happen with this nitrate particle is denitrification. So in denitrification, this happens when we have saturated soil conditions. If you think about those areas of ponding, when we're going through very wet periods, typically it's been here in early to mid-June, but we have bacteria in the soil, denitrifiers, that operate under very low oxygen levels, and they turn that nitrate into nitrogen gas, which we then lose to the atmosphere. So let's talk about the most widely used form of nitrogen fertilizer in the world, which is urea. Urea is a very easy to use fertilizer. It's a dry prill. It's very easy and safe to handle when you consider its counterpart, anhydrous ammonia. So urea is in a form, it's got carbon attached to it, so it's organic. Eventually, this form of nitrogen, this urea, will eventually become our stable form of nitrogen as ammonium. But it's got some work to do before that. So when we apply it, we're going to get some water there with it, and the urease enzyme is going to change it to there's going to be some ammonia and carbonic acid. And then very shortly after this, it's going to turn it to ammonia gas and carbon dioxide. Now when we have loss, when we have the conversion, when we don't have water to put on here, this conversion with this urease and then to here, we can lose this ammonia as gas. And that is the process called volatilization. So when we surface apply urea and we don't get an incorporating rain and it's not incorporated into the soil where it's going to be able to find ample moisture, ample water, then we can lose it through volatilization. There are products that we can coat on our urea, we can blend into our urea, which will stop this urease enzyme from being active. It doesn't stop it indefinitely. It's going to coat this urea and keep this urease enzyme from turning it to ammonia gas. Now this basically is going to give us a 2 to 3 week window where we can get time to get out there with a piece of tillage equipment to incorporate that nitrogen, or give us time so that we can get a rain to incorporate it that way. So under ample moisture conditions, so we've gotten rain or we've got moist soil that we've incorporated it into. So we've got our ammonia, NH3, and then we get some more water, and then we're just going to have that same reaction that we had with our anhydrous ammonia, where we've got our stable form. We've got our stable form of ammonium right here, but then we're also going to see it's not totally safe, because then eventually we're going to have that reaction with those soil microbes turning it to nitrate. So when we apply urea, our first thought is about keeping it from loss through volatilization when that gas goes up, and then we want to have enough water on there, whether it's rain or incorporate it with the soil, so that we can get that water and turn it to our stable form of nitrogen right here. So now we're going to take a look at our nitrogen solutions, which is UAN. So we've got our two different forms, 2800, 28%, or 3200, 32%. So 50% of the nitrogen in UAN is going to be in that urea form. So if we aren't incorporating this nitrogen, this UAN, or if we aren't going to get an incorporating rain, we can lose this 50%. We can start losing that to volatilization. And then we've got about 25% of that is in that nice, stable ammonium form. And then we've got about 25% of that is in that another form that the plant can use, but that can be lost to leaching. So this urea portion, if we don't incorporate it, we can lose it to volatilization. Otherwise, it's going to be converted with ample moisture. It'll be converted to that NH4, that stable ammonium. So we like this form of nitrogen. The plant needs it. It's also very stable. So we're going to have about 75% after application is going to be in that ammonium form. So something that we can do for UAN solutions, there's two different stabilizers that we can use. A stabilizer is going to be like Instinct, which is the liquid form of NSERV. So that Instinct is that nitropyrin again, which is going to stop the conversion of ammonium to leachable nitrate. Something else that we can do is, if we are not planning on incorporating, or if we're coming up into a dry period, we can use products like Limus or Agritane, which are those urease inhibitors. Now it is a little bit cost prohibitive to think about using both the Instinct, the nitrification inhibitor, or urease inhibitor in this one application. So if we're trying to decide which nitrogen management product to use when we make our UAN solution applications, what are we going to be doing to that soil afterwards? If we're going to incorporate our UAN solution shortly after, or if we're going to get a rain after, then using a urease inhibitor probably isn't going to benefit you as much as what a nitrification inhibitor will. So if we're going to be incorporating it right away, I would suggest using a nitrification inhibitor, which is going to be influencing a very large portion of the nitrogen that we've put in. But if you're going to be leaving it on the surface, then I would suggest a urease inhibitor, particularly if it's going to be dry. but then you're only keeping it here. This last 25% here that is in the nitrate form to begin with, there's not anything really that we can do to stabilize that, so you're just going to have 25% that's going to be available to leach from the word go. I hope you enjoyed and learned something from our nitrogen discussion, and I look forward to seeing you again on our next installation of Nicole's Crop Classroom.